Find a possible solution to f of x given that f of x equals x squared 2 to the x plus x over x squared. Okay, so first thing we'll do is we will try and rewrite this as best we can. So we'll distribute the denominator between both the x's. It's kind of weird how I write x like that, then I also write x like that, all curly. Weird. Strange. I don't know why that is. I should know why that is. I don't. Alright, x cancel. And you're left with x to the negative 1. And so we're left with the integral of 2 to the x plus 1 over x dx. And so the idea is if you can break up the fraction into break up the denominator, you should really look at that. That should be one of the first steps you should look at for most problems. This one worked out well because that way I got rid of that x squared in front of 2 to the x. Okay, so first part I'm going to look at, and we can break these up and do them separately. We can do the 2 to the x on one side, and then 1 over x second. I'm going to do 2 to the x first because I think it's the harder one, and I like to get the hard work done first. And so if we look at 2 to the x as an integral, we'll start by saying that, all right, so this is e natural log of 2 to the x, which equals e to the x natural log of 2. And we know that the integral of e to the x is e to the x. But another way we could look at this, so we have integral e to the x dx. This is, to be extra formal about this, we'll say that u equals x natural log of 2. du then equals dx natural log of 2. So du over natural log of 2 equals dx. Okay, so now we have a u for x ln of 2, and we have a substitution for dx. And substitution is just going backwards on the chain rule. Is the inverse of the chain rule. So we have something like e to the u du over natural log of 2. We know the derivative of e to the u, that's just something that we memorize. And that will be, get rid of the derivative thing, e to the u over natural log of 2. Yep, derivative of e to the u will be e to the u. And then we'll do, there's a plus c, but I'm going to leave that off for now. And then substituting back in the x ln of 2, we have x natural log of 2 over natural log of 2 equals e to the natural log of 2 to the x all over natural log of 2, which equals, those cancel out, and we have 2 to the x over natural log of 2. Now you can memorize this or not. You can, what I'm saying is you can memorize that the integral of 2 to the x is 2 to the x over natural log of 2. One way to remember that, or at least kind of get a cue that that's the correct way of doing it, is you can look at it, e to the x. E is just a constant. So when you take the integral of e to the x, that's actually e to the x over the natural log of e. Natural log of e is just 1, which is why this just becomes e to the x. You can memorize or not. I usually don't. I probably have to go through the steps every time. You don't see this integral come up that often. And so for me, it's easier to work through it every time than to try and memorize that specific integral and then risk getting it wrong. Okay, so we know the first part, and then we know that the integral of 1 over x is natural log of x, absolute value. And so this would equal 2 to the x over natural log of 2 plus natural log of x plus c. Look over here at our possible answers, and 2 to the x, natural log of 2 plus natural log of x. Sounds good. And the reason that plus c is left off is because this is asked for a possible solution. So I guess if c equaled 0, this would be a possible solution. And so the idea here is, yep, that's correct. So backtrack, big picture. We have our equation, x squared to the 2x plus x over x squared. We simplify it by distributing that x squared and breaking up the fraction into 2 parts. And then we just basically have the integral of 2 to the x and 1 over x, both of which aren't that easy, but we can do it. Very possible. This is the sort of question you could expect to see like on an AP exam, and you could be expected to solve it in 2 to 3 minutes. So not too bad. Very possible. See you on the next question.